Hi, for my power electronics laboratory subject, this is experiment 6. It is entitled Controlled Half-Wave Rectifier Circuit with RL Load. So the objectives of this experiment. So the first is to simulate the controlled half-wave rectifier with RL load using PSpice software. Next is to determine various quantities such as average load current and RMS load current using PSpice software. So for the procedure, first is we need to open PSpice and create this circuit. So it is we're asked to set the variables to resistor has 20 ohms and inductor is 40 millihenries, and these are the other settings. So let's do that. In this experiment, we need to use our CAD application. So upon opening the application, first what we'll do is we'll make the circuit. So to do that, new project, experiment 6, create blank project. Next is to make the circuit. Now let's make the circuit. On this part, I'm adding a parameter. So let's edit the setting of the parameter. Click on new property, name it alpha, value is 45. Click OK, and here we're going to display the value and the name and add another frequency, 60, and click on OK and find frequency here. There, I'll just repeat it. I'll add the value of 60, apply. There, I forgot to apply it. Then display the name and value also. And as you can see here, parameters, we have alpha 45 and frequency 60. Here, let's put the equation. Alpha over 360 over 60, close bracket. Also, for the period, the formula is 1 over frequency. This is for the values of the V source. Control rather, V control. Let's edit the simulation profile. Runtime is 16.67 milliseconds. And maximum time step is 10 microseconds. So running the simulation, need to edit the axis variable so we can display um, the time based on angle. So time times 60 times 360. Click OK. So here, let's check if the value of the firing angle is really at 45, because we set in the parameter 45 degree or 45 for the alpha. So here we have the waveform for the current in R1 and L1. As you can observe, after this zero crossing, the SCR turned on at 45 degrees. So this means that our setting is correct. So here 40, 45, in between 40 and 50. So next, let's check for the average load current when the firing angle is 45 degrees. So to do that, let's delete this traces, add trace average current for IL1, and also let's add the average current for R1. So here we can observe that they have the same waveform. So turning the cursor on and putting the cursor at the very last of the waveform, we can observe a value of 1.9515. This means that this is the average current for the inductor and the resistor, 45 degrees. So next, let's measure for the RMS load current. So same um, variable. Let's just change it to RMS for R1 here. This is the waveform. So turning the cursor on, it read the value of 3.1325 RMS load voltage when the firing angle is at 45 degrees. So next, let's edit. Let's check if we're going to change the firing angle to 90 or a greater value. Let's delete this and play the simulation again. So the same procedure. Let's check, or let's change first the plot axis. Here, axis settings, the axis variables. Let's multiply this to 60 and 360 so we can interpret the values of per second in terms of degrees. So again, we're going to check for L1 and R1. Here, as you can observe, it changed the firing angle, changed to 90 degrees. Also, it can be observed that the conduction was shorter compared to the conduction earlier at 45 degrees firing angle. So let's add another trace. Let's check for the average current in L1 and average current in R1. So let's turn on the cursor here at firing angle at 90 degrees. So we have a value of 1.0745 when the firing angle is at 90 degrees. Next, let's check for the RMS load current. RMS, there, R1. Turning the cursor on for 90 degrees firing angle, we have a value of 9.0172. Next, let's further decrease the firing angle to 20. So this is the least angle that we're going to test. Smaller, even smaller than the 45 degrees angle earlier. Same, change this to 60 times 60 times 360 to interpret seconds in terms of angle. Let's add trace the inductor and the resistor current. As you can observe, this is at 20 firing angle, and it had a greater conduction compared to 45 degrees earlier. So by this we can conclude that the least firing angle, the greater the conduction, and the greater the firing angle, the least the conduction. So here again at 20 firing angle, this is the average load current for the resistor and the inductor has a value of 2.2643. And lastly, for the RMS, when angle is at firing angle is at 20 degrees, let's check for RMS. Let's measure the value. Here we have a value of 3.4237. This is a summary of the results obtained for 20 degree, 45, and 90-degree angle of the firing angle. So as you can observe, as the firing angle increases, the average load current and RMS current um, changes accordingly. When the alpha is 20 degrees, or when firing angle is 20 degrees or low, average load current is at its highest, and as well as its RMS load current. And as the firing angle increases, um, the average load current decreases. This means that the greater the firing angle, the least the conduction is, or the current for conduction is.